a tube of length 1 meter is filled completely with an ideal liquid of mass twice m and closed at both ends. The tube is rotated uniformly in horizontal plane about one of its ends. If the force exerted by the liquid at the other end is F, then angular velocity of the tube is root over F by alpha m in SI units. The value of alpha is. So here it is said that there is a tube of length 1 meter. So tube of length 1 meter with an ideal liquid of mass 2m, that is ideal liquid, that is incompressible, non-viscous, closed at both ends. The tube is rotated uniformly in horizontal plane about one of its ends. Let's say the tube is rotated about this end. So about this end the tube is rotated, that is rotated like this. This end is fixed, end A is fixed. If the force exerted by the liquid at the other end is F, so the liquid exerts a force at the other end is F. Find the angular velocity of the tube is. So when it is rotated about A, then we know the centrifugal force is equal to m omega square r. Now consider the mass is uniform, as the liquid is uniformly distributed and completely filled. So we can easily assume that the total mass is at the center, that is total length is 1 meter. So this center of mass is at half meter from the axis of rotation is half meter, and the total mass, let's say the total mass is concentrated at this point of center of mass. So the total mass is 2m, is concentrated at center of mass cm. So the force, centripetal force or centrifugal force is m omega square r. So m is twice m. This is the mass of the liquid. Omega is the angular velocity, omega square r is half m omega square r, and this is the force, this force is exerted by the liquid. So this is equal to half. So 2 cancels, omega square is equal to F by m. So omega is equal to root over F by m. Now in the question it is given that omega is equal to root over F by alpha m. So if we compare these two, then we can easily write alpha is equal to 1. So the value of alpha is 1. Thanks for watching. Please like this video, subscribe my channel and share this video.